And thank you, Vicki, for telling me I didn't have a full recording out there. I didn't realize that. So I did post it. And I think it's going to help you, especially Vicki watched it before class, so it's going to help you. All right, so we're going to solve some logarithmic equations, some exponential equations here. And we're going to use the rules of logs. So this is the rules of logs. If it's easier to do this, but you can only do this if you can match the exponent. So we're going to use logs on this one. And this one is a little more complicated, but we'll be using this eventually, once we get it. So this was just, that stuff was just right from here, the little boxes in your notes. Okay? So here's an equation. It's e to the 2x minus 2e to the x minus 3 equals 0. And this actually, you can rewrite the e to the 2x as e to the x squared. And this is going to factor. Have you ever tried to factor anything like this? No. So if it helps you to see the factoring, you can make a simple substitution, and we'll do that a lot, especially in calculus. We're going to go ahead and if you can see it without doing the substitution, you don't have to substitute. Let u equal e to the x. Does everybody understand why e to the x squared is the same as e to the 2x? That was the power to power rule of exponents. So we could, if you're taking e to the x raised to the second power, you multiply. You'll get e to the x times 2 or e to the 2x. Okay, so we're going to let u equal e to the x. So we have u squared minus 2u minus 3 equals 0. Now, that should look easier to factor. Does that look easier to factor? It factors. We're going to factor it. It's a trinomial. It factors into two binomials. You'll have a u and a u. That gives you your first term. U times u is u squared. And then the only factors of 3 are 3 and 1. So if we put a 3 here and a 1 here, okay? And then because we have a negative sign, we need opposite signs for the factors. Because the middle, so in order to get, so one of these has to be negative. Either the 3 is negative or the 1's negative. That's, in order to get a negative last term, you have to have opposite signs. And they add up. The factors of negative 3 that add up to negative 2. Since you got a middle term that's negative, the bigger number is going to be negative. You can check that out. You can FOIL it. The inner term is minus 3u. The outer term is plus 1u, and that adds up to minus 2u. So you can FOIL it out and check off on scrap paper if you need to. So, and then we set each factor to 0. U minus 3 equals 0. Or u plus 1 equals 0. So u equals 3, or u equals negative 1. Okay? Now we're going to remember what u was, because these are not our answers. U was e to the x, so we put e to the x equals 3, or e to the x equals negative 1. And now we're going to solve these using, we're going to use logs to solve this exponential. Because we got e's, we're going to take the natural log of both sides. So we've got the natural log of e to the x equals the natural log of 3, or the natural log of e to the x equals the natural log of -1. And these cancel. This is base e, and that leaves you with x equals natural log of 3. That's one answer. And we remembering what the natural log function looks like, this is base e, so it looks like this, and this is a vertical asymptote. So I told you, I drew the picture so you could see we can't take a log of a negative number. Because it's not in its domain. I just drew the picture. So there's no solution from this part, but we do have a solution. It's natural log of 3. And we can check it with our calculator by putting it back in. We can put natural log of 3 in everywhere we have an x up there, and you will get 0 if you do that. Oh, and so if we want it to 2 decimal places, we're going to put it in our calculator. We want an exact answer in terms of natural log, so that's the exact answer. And the approximate answer to 2 decimal places is that it's approximately 1.10. Those are the two answers I wanted. If we put 1.10 in for x, we're not going to get 0 up there. It's not exact enough. But does anybody want to see me put it in, or do we want to keep going? You know, you can put this in the calculator. You know how to do that? Any quiet? Okay. Let's not, and say we did. Let's not take the time to put that in my calculator, but you could put natural log of 3 in for x. In fact, you could press store and store this into x. Now I have my answer stored into x. Now my x has saved, my x has natural log of 3 stored. So now I could do second e to the 2x, close the parenthesis, minus 2 second e to the x, I have to close the parenthesis though, minus 3. And if I hit enter, I'm going to get 0. See what I did? I did something tricky. I pressed the store button, and it stored my answer that was on the calculator into the variable x. And then I was able to just type the equation and it's shown. Making sure you close those parentheses in the right place, and I could check it that way. Okay? So it doesn't take that long to check. These are equations you can check to work. All right, let's do the next one. Any questions? Okay. All right, so it does help to do that. Let's do the next one, and I'll just take up this room here. Okay, I have a problem like this on the test, and that's why this is added to the notes. Okay, we have 3 to the 2x minus 1 and equals 7 to the x plus 1. So could we rewrite the 3 as base 7 or the 7 as base 3? That would not be easy. And that's why you're going to take the natural log of both sides of this one. So, I don't know. Oh, here's the card. So, we're going to, we can't rewrite the 3 3 in terms of base 7 or the 7 in terms of base 3. So we can't do 1, so we're going to do this one. So it's base 3 and base 7. So we're just going to take the natural log of both sides. And it's a single exponent equals a single exponent. So we take the natural log of both sides. 3 to the 2x minus 1 equals natural log of 7 to the x plus 1. Okay? Now we can use the power rule. We're going to bring the exponent out front and multiply. We're using the power rule. So this is going to be brought out front, and we're just multiplying. So we have 2x minus 1 times natural log of 3 equals x plus 1 times natural log of 7. Now we type natural log of 3 in our calculator. It's just a constant. But I want you to leave it as natural log of 3. It is a constant. So this is just a constant times that, and a constant times this. So we're going to distribute it. If you want, you can write the natural log of 3 in front, or we can make sure we just distribute it. We're distributing. This is just a constant times 2x is 2 times that constant times x. So x is not inside the natural log. That's why I put the parentheses there. And then minus 1 times natural log of 3 is minus natural log of 3. I'm just distributing. Okay, x times natural log of 7. I'm going to write the constant first. Natural log of 7 is a constant times x. And then plus 1 times natural log of 7 is natural log of 7. Okay, so I have, this is just a constant. This is just a constant. This is a coefficient in front of an x. This is a number, a constant in front of an x. So we want to, our highest power is x. We want to get all our x's on one side, all our constants on the other. So we're going to subtract. I'm just going to move the x's to the left. So I'm going to subtract natural log of 7 times x from both sides. And by moving my x's this way, I want to move my constants this way, so I'm going to add natural log of 3. Okay, so we have 2 natural log of 3 minus natural log of 7 all times x. I kind of skipped a step. I would subtract these and then factor the x out, but this cancels here, this is canceling there. On the other side, you cannot combine natural log of 7 and 3, natural log of 3 and make it natural log of 10. You're adding natural log of 7 plus natural log of 3. You could write it as natural log of 21, but we're not going to do that. It's just natural log of 7 plus natural log of 3. It would be wrong to write that. So, yeah, just don't do natural log of 7 plus natural log of 3 is not equal to natural log of 3 plus 7. That's not the rule. It's times. And we don't need to do this. We're just leaving it like that. But okay, so now we have, this is a constant. We have something, a constant times x equals a constant. So we're going to divide through by this horrible looking constant. 2 natural log of 3 minus natural log of 7. 2 natural log of 3 minus natural log of 7. And you don't need to condense the right side here. You could, but you don't need to. So that's the answer, that's the exact answer for x. And then I want an approximate answer to 2 decimal places. So you have to put this in your calculator carefully and get the decimal approximation. Natural log of 7, close the parentheses, plus natural log of 3. It opens up a parenthesis, you've got to close it. That's the numerator. It opened up a parenthesis here, I had to close it. Opened up one here, I closed it. I forgot to put parentheses around the whole numerator, so I can hit enter, and that'll give me my answer to the numerator, and then divided by, and then I do need a parenthesis here, the denominator, 2 natural log of 3, but I have to close the parenthesis. The natural log stopped. It opened up one up, we got to close it. Minus natural log of 7. The subtraction sign, natural log of 7. And we can close that and close the whole thing, or we could have just, the last couple parentheses, the calculator knows if you hit enter, it'll close things out. But, and you get 12.33, or no, 12.11. Okay, that's approximately 12.11. So if you put 12.11 in there, you're not going to get the exact answer, it won't be equal, but you can do store into x, and then you can type in the left side of the equation, 3 to the parenthesis 2x minus 1. You can only do this if you've stored the answer into x. You get 1.21 times 10 to the 11, and 7 to the x plus 1. And you're going to get the same huge number. So those are equal. So I checked it using the calculator, storing that answer into x. All right. Now we're going to solve logarithmic equations. So that was solving exponential equations. Now we're going to solve log. One way is to just use the definition. We know how to solve exponentials if we can get a single log on one side equals a constant. We can rewrite it as a log, and then we already know how to solve that. That's the first way, and the other way is if we can get the log of the same base of a single thing. A single log equals a single log, same base. Then we can let m equal n. And you can also go the other way. Okay. So, and check the domain. Remember, there's no logs of zeros, and we can't take logs of negative numbers. So this is basically the two ways to solve log equations. We either use the definition, or if we can get a log equals a log of the same base, we set these equal. Solve. Okay? So we are expressing then the equation in the form the 1 where is it? Log base b of m equals a constant. We do need to make sure there's a understood coefficient of 1 here. And it has to be a single log. So if we have it in this form, then we can use the snail and change it to b to the c equals m. Solve for the variable, check it, in the original equation. Make sure that the domain's okay, but I say you can remember that you can't take log of 0, no matter what the base, or log of negative numbers. So you have to cross out those solutions where they make you take a log of 0 or a log of a negative number. So that's what you can do. Students find this easier than finding the domain every time. Okay? Okay, so we're going to solve each logarithmic equation. So here it is. We have a single log equals a constant. So it's the base to the exponent equals the inside of the log. 2 to the 5 equals 4x plus 1. We rewrite that as an exponent. And now we don't have to take natural log of both sides or anything. 2 to the 5 is a number like that. Do it in your calculator, it's 32. And now we can solve this. We want to solve for x. So we have to get all our constants on one side. So I'm going to just move the 1 this way. We get 31 equals 4x. Divide by 4. So x equals 31 divided by 4. That's our answer. And so 31 divided by 4 as a decimal equals exactly, also equals 7.75. Okay, so we can check this. We can put this back in our log equation. Log base 2 of 4 times 31 divided by 4 plus 1. The 4's cancel. 4 divided by 4 is 1. Log base 2 of 31 plus 1 is log base 2 of 32. And so that equals 5. You rewrite 32 as 2 to the 5th. 2 to the 5th. I've run out of room. Sorry. Okay. And so that checks. Some of you have calculators that do logs of different bases. Or you could use the change of base property to check it. But some of you have you do have calculators. This calculator does not do logs, but I mean of different bases. But somebody told me it was alpha window, which does nothing for me. Try alpha window on your calculators. And that gives you different bases, the choice to do. Does yours do that?
Yes.
Okay. Does it? The calculators on the computers don't. Do you do something? Absolute value. Function, fraction. What does it look like on yours? Maybe.
It's an alpha window.
Oh, alpha window, and you have to go down to 5 and hit enter.
How do you do it?
Oh,
You can't do that, can you?
see, your x is defined as, if you define your x as 7.75 and type that in, then it will give you 5. You have to type in times 7. You can use, okay, you can do you had, what was it? 4 times, second insert, 7.75. Oh,
That's
no.
okay.
Anyway,
That's all right.
no,
This just makes it worse for me.
it does. Did you go down to 5?
Yeah.
Did you do it? Okay. Remember though, when I asked you guys, did your calculators do it too? On the take-home test, when I ask you to use the change of base property, you have to use the change of base property. Because, and that's how the calculator is doing these different
That makes
bases.
sense.
In the background, they have the change of base property program.
Put in the number.
What's the change of base property? The change of base property is that the log base A, B of anything can be rewritten as log base A of the inside of that log divided by log base A of the original base. And so what we do with that, since the calculators only had log base 10 or natural log, we did this. This is the change of base property. Okay? This is a change of base property that if I ask you, and I do, on the take-home test, to use the change of base property to find a log that's not base 10 or natural log, you're not supposed to press alpha window. You can check your work doing that. But you're supposed to write this and then type this in your calculator. I won't be able to tell whether you typed this actually in your calculator, but this is showing your work. You're gonna have this written down or this written down, and then you give me the answer. So I won't be able to tell if you actually did it this way, but this is that's the work. Okay? Any questions on the change of base property? So I could find, so if I wanted to find log base, this is kind of complicated, but if I want to find log base 2, this is log base 2 of 4 times 31 divided by 4 plus 1. I could find it by doing log of 4 times 31 divided by 4 plus 1 divided by log of 2. You see, because my calculator doesn't have the extra thing, but this is just the change of base. Log of 4 times 31 divided by 4, or 7.75, plus 1, which is just 32. That divided by log of 2 gives you 5. I just used the change of base property to show that this problem worked instead of having to go back and use the properties of logs to prove it. You guys remember the change of base property? Not really. Any questions? Change of base. I just want to see one step. You're going to write this over this, or else you don't. It's worth 2 points. You're going to get 1 point if you don't show that step. All right. Okay. So the next one, we got to make sure we isolate the log. Let's get rid of the calculator. Okay, we need to get this by itself. It's being multiplied by 6, let's divide by 6. So we get natural log of 2x, and we don't have to keep 30 over 6 because that divides evenly and it's 5. Okay, So now we have a single log equals a constant. We can, and the base is e. Natural log's understood base is e. So now we can rewrite this as an exponent. E to the 5 equals 2x. E to the 5 equals 2x. Okay, don't take the natural log of both sides all of a sudden. E to the 5 is a constant. So if you put that in your calculator, so there's no x in this one, so that's a constant. We're just going to solve for x by dividing by 2. The exact answer is that x equals e to the 5 divided by 2. The approximate answer to 2 decimal places is we put this in our calculator. Second natural log e to the 5, close the parentheses, and then divide by 2. It is a constant. And so we get 74.21. And you can check that. So we check, is 6 times natural log of 2 times e to the 5 divided by 2, does that equal 30? We're checking. So 6 times the natural log of 2 times second natural log, which is e to the 5. I have to close the parentheses and divide by 2. Close that parentheses, and does that equal 30? If you don't do the parentheses right, you're going to get the wrong answer, though. So I just checked it. It may be easier to check by canceling here, and then we have 6 natural log of e to the 5. Those cancel. You're left with 6 times 5 is 30. Okay, so when you type things in the calculator here, it keeps adding parentheses. You've got to close them when you're done with your exponent. When I put this in, it added a parenthesis here, and I had to close it. Okay? So this is using the properties, the definition of logarithm, to solve logarithm equations. The last example is that we need a single log with a coefficient of 1 in front equals a constant. We have a constant on the right, but we need a single log, so we need to condense. So we're going to condense using the product rule. It's a plus sign. So this and the bases are the same. You can only condense if the bases are the same. But I don't do tricky things like give you different bases. That's a good idea. All right, so you condense this. This is a single log of x minus 1 times x plus 1. And that equals 3. Log base 2. That single log. So now we rewrite this as an exponent. So we get 2 to the 3rd equals the inside. 2 to the 3rd equals that whole inside. X minus 1 times x plus 1. So I don't mess up my paper too much. I can show you. Okay, I should use this one. X minus 1 times x plus 1. If you FOIL it, you get x squared. You have to FOIL it, plus 1x, outer term, minus 1x, and minus 1. So these cancel, and you get x squared minus 1. So x minus 1 times x plus 1 is x squared minus 1. You guys all see that? Okay. Okay, so we have 2 to the third, which is 8, equals x squared minus 1. Now if you have an x squared term, you have to subtract the 8. You set it to 0. X squared minus 9. Well, how does x, and this is if you're going to factor. How does x squared minus 9 factor? It factors into x plus 3 times x minus 3. That's the difference of perfect squares. You should have that memorized. It always factors. You know, a squared minus b squared always factors into a plus b, a minus b. Okay, so you're going to factor that. So we're continuing to solve. To solve quadratic equations with x squared as your highest power, you set it to 0 and you factor. And if you can't factor, you use a quadratic formula, but you'll be able to factor. So 0 equals x plus 3, x minus 3. So that means either x plus 3 equals 0 or x minus 3 equals 0. So x equals negative 3 or x equals 3. All right, then put this in the, you have to check your domain. So if we put negative 3 in the first log here, x equals negative 3, we get log base 2 of negative 3 minus 1. That's log base 2 of negative 4. That's a log of a negative number. This is not a solution. We sometimes get extra solutions here. We can't use that one. Because we got the log of a negative number. Check x equals 3. So we're going to put it in the original equation. We get log base 2 of 3 minus 1 plus log base 2 of 3 plus 1. So that's log base 2 of 2 plus log base 2 of 4. And you could check that. Fine, if you want to check that. What does this equal? That equals 1. What does this one equal? It's 2, because 4 can be written as 2 squared. And 1 plus 2 does equal 3. But you can also use your fact that your calculators do bases of 2. So you could, somebody in my first class told me about that.
So why did you cross out the negative 3? What was the reason?
Okay. Because I put the negative 3 into the original expression, and I got the log of a negative number.
Yeah, you can't have that. So
That's why I crossed it out. Okay, good question. All right. So the answer is just x equals 3. This is your answer, one answer. So could you just try some numbers and see, plug in? Yes, you can do that, but the answer itself is going to be worth like half a point. I want you to solve it this way. Okay? There's other ways to solve it. At this point, it's fine if you want to use different methods to solve quadratics. If you want to use a quadratic formula here, you could, or if you want to set this is equal to 9 and take the square root of both sides, that's okay, you know. If you don't like factoring, I just happen to love factoring, did you notice? It's like a little question.
So at 8 equals x over 2 minus 1, could you just square root both sides and cancel your square root out? Or
Yes, you could, at this point, right here. Well, you can't square root both of these at this point. Once you, okay, let's redo that. Let's start from 8 equals x squared minus 1. You could add 1 to both sides, and you get x squared equals 9. Okay? And then you can take the square root of both sides, but remember, you have to add a plus or minus sign there. And to get full credit, so x will either equal 3 or negative 3, you have to check the domain and cross out the negative 3. Okay? So there is another way. Factoring is just my favorite, but on the slides they did a lot of this. If you have x squared equals a constant, you can take it to both sides. Okay? All right. That's how you solve logarithmic equations, if you can get it into this form. And the other one is here, using the one-to-one property. Do you guys need a break before I do this? If you can get a single log on the left equals a single log on the right with the same base and coefficients of 1, then you can say that the insides are equal. Do you guys need a break? Any questions? No? All right, we'll keep going then. Do you need a break?
no,
Okay. All right. I can keep going. All right, so this is what we're doing. That's what all this says. No, I simplified it. Okay? I just told you what it says. Just make sure you have a coefficient of 1. You can use the one-to-one property. You can go this way or you can go the other way. And then you do need to check this proposed solutions in the original equation. Again, you make sure there's no logs of 0 and no logs of negative numbers. And my students all find this easier than checking that. Okay? All right, so we're going to do this. We need to get a single log on the left equals a single log on the right. We got a single log on the right. We're going to condense this to get a single log on the left. So this is why we have to know how to condense. We have all log base 2s, so we're going to get a single log, and we're adding here, so this is going to be x times x minus 3. And we're subtracting, so this is going to be x plus 2 equals log base 2 of 4. Okay, we have a single log equals a single log. So we can use the one-to-one property that says that the insides must be equal. Or we could raise both sides to base 2, and these will cancel. So you can also raise both sides of an equation to the same base. And these cancel. These are two ways to do it, and that's why there were two answers to some of those questions on the little quiz in Socrative that we'll go through in a minute. So you set the insides equal because we had a single log equals a single log, or because it was log base 2, we raised both sides we had to raise the entire sides to base 2 to cancel out the log base 2. Because then we had a 2 and a 2, and it canceled. So either way you want to do it, base 2. Okay, and now this is where you got to be able to solve equations. Now we're back. So we've got this equals this. X, I'm going to distribute this. It's x squared minus 3x over x plus 2 equals 4. Okay? We can multiply both sides by x plus 2 to solve this. We want to get rid of this denominator, so we multiply by x plus 2. If we do it on this side, we got to multiply this by x plus 2. That cancels, that's why we multiplied. So don't FOIL this out on the left side. So we have x squared minus 3x equals, and distribute this, 4x plus 8. We have x squared as a highest power. So we're going to get all our terms on one side and set it to 0. We want to leave the x squared to be positive. So we're going to subtract the 4x from both sides. And we're going to subtract an 8. We'll fit it in here somewhere, okay? This will be 0. So we get x squared minus 7x minus equals 0. Then we're going to factor. These are going to factor. So the factors of negative 8 that add up to 7, of course we'll have an x and an x, negative 7, are minus 8 and positive 1. That adds up to negative 7. So you set x plus 1 equal to 0, so x could be negative 1, or x minus 8 equals 0, x could be 8. But now we need to check. We get extra solutions here, so we got to check. We're going to just put the negative 1 in the first log. Log base 2 of negative 1 minus 3. That's going to be a log of a negative number. That's going to be log of negative 4. So if any of those logs on the original equation give you a negative inside of them, that solution does not work. Okay? And now I can check for x equals 8. Let's put that in. Log base 2 of 8 minus 3 plus log base 2 of 8 minus log base 2 of 8 plus 2. And so that's log base 2 of 5 plus log base 2 of 8 minus log base 2 of 10. And if you guys want to check that to make sure that that is log base 2 of 4. And it is. I can condense that. Log base 2 of 5 times 8 divided by 10. 40 divided by 10 is 4. Log base 2 of 4. So I condensed it, but you could check with your calculators that do the different bases. And the last example on this one is, any questions? I should have given a little less time for test 2 material, a little more for this one. material, I think. But next fall, I had to pick, and my test date fell on Halloween. And they said, you can't have a test date on Halloween for internet people. They're not going to come. They have kids. You can't come on Halloween. So I had to choose the day after. So we're going to have to just go ahead before our third test. We're going to have to cover a lot of log stuff. I don't know how else to do it. But yeah, here we are trying to get through this. But sorry about that, guys. Okay. The last one, we need a single log equals a single log, so we're going to condense the left side. So we're subtracting, so this is going to be log of x plus 7 divided by 3. And that's base 10. If it doesn't say the base, it's 10. It's LOG, base 10. We don't have to write the base. Now, this is a single log equals a single log, same base, so the insides must be equal. So x plus 7 over 3 has to equal 7x plus 1. So I can multiply by 3 times 3. Okay, this is, so we could cancel that, so x plus 7 equals 21x plus 3. It's just an x and constant, so we want to get all our x's on one side, this is 1x, and all our constants on the other. If we want to keep x positive, we'll subtract 1x. Doesn't matter which side you put them to. I'm moving x's to the right, so I'm going to move the constants to the left. So I get 4 equals 20x divided by 20. X is 4 over 20, which reduces to 1/5, or 0.2. Now, can we put that in here? We can even check this. This is plain log. So we're going to check. Log of 7.2 minus log of 3. Does that equal log of 7 times 0.2 plus 1? So we'll put that in our calculator and check. Log of 7.2, close the parentheses, minus log of 3, close the parentheses. What it equals? Log of 7 times 0.2, or 7 divided by 5, plus 1, and it's the same decimal. So we got the same decimal, so they are equal. So that equals 0.3802. So you should always check. Okay. We have one more page for this section. This is it. Any questions on that? Okay. This is why after the third test we should have stayed the extra half hour. Too. You know? At the time we were really just tired. And we could do it. This is what the 3-hour classes are like, though. Okay, so the last page is really a word problem, like something we're going to work on in the next section. But so here's a formula. This models the population of Texas in millions T years after 2010. So T years after 2010 means that in 2010, T will be 0. So T equals 0. So what was the population of Texas in 2010? So we just fill in T equals 0. A equals 25.1 e to the 0.0187 times 0. Well, anything times 0 is 0. So you get 25.1 e to the 0, and anything raised to the 0 power is 1. So that's 25.1 times 1. So the answer is 25.1, and it's in million. And the reason that's the answer, this is the initial amount, this is, and the next section is represented by A subscript 0, the initial amount. And plugging in 0 on this kind of equation will always get you this number. You could put it in your calculator, but you don't need to on here. Okay, when will the population of Texas reach 28 million? Now they're telling us A equals 28 million. What is T? And we're going to just round to the nearest year. Okay, so the equation is 28 equals 25.1 e to the 0.0187 t. So we're solving an exponential equation. We need to isolate the exponential expression and then either take the log or natural log of both sides. So this is the exponential expression. We need to get this by itself on one side. So we're multiplying by 25.1. We're going to divide by 25.1. So we have e to the 0.0187 t equals 28 divided by 25.1. Don't put this in your calculator and round it to one place. We're going to leave it as an exact answer in terms of natural logs. We want our exact answer first. So you're going to take, now that you've got e by itself on one side, you can take the natural log of both sides. We're usually going to take the natural log of both sides. And these cancel. So we have 0.0187t equals the natural log of 28 divided by 25.1. And then we divide by 0.0187 to get t by itself. So here's what t is. We put that in our calculator carefully, round to the nearest whole number. So it's natural log of 28 divided by 25.1, close the parentheses, and then divide by 0.0187. And that is 5.85, so it's t is approximately 6. That's not our answer. What year would it be? So we have to take 2010 and add 6 to it, is 2016. So Texas reached 28 million, according to this model, in the year 2016. And that's section 3.4. So I'm gonna stop the recording.